In this example, I'm going to show how to output floating point numbers with streams. The example code is located in this function here, which I've defined in this file here, demo floatingpoint.cpp. So I have various different numbers output in various different formats. I'll lead you through the example and I'll output it as we go through each bit so you can see how it works. So first of all, we have three numbers. Pi is a relatively small number with quite a lot of accuracy. S is a very big number, 1.989 times 10 to the power 30, and n is a double, but effectively it's just an integer number. So I'll just skip over the precision part for a moment. We'll come back to that later. When it comes to outputting numbers, floating point numbers, there are three different ways to do it. You can output numbers in general format, or in fixed format, or in scientific format. The default is general format, so we'll have a look at that first. So in general format, C++ decides how to output the numbers based on the best format for that particular number. So if I run the application, and I'll show you what it looks like first off. So we've output pi and s and n in general format. That's the default. And as you can see, it's chosen to output pi as 3.14159. Notice that it seems to have lost some of the digits. That's to do with precision, so I'll come back to talk about that a bit later. It's output s in scientific notation because it's very large, and that's the best way to output a large number. And n, well, n is just 42.0, so it's chosen to output that as just an integer value because that's the best way to output integer values. Okay, so that's the general format. Basically, C++ decides the best way to output each particular number depending on what it is. So back into the code. The second way of outputting floating point numbers is to use fixed format, and that's what we do here. To use fixed format, you use the std fixed manipulator. And the fixed manipulator will cause numbers to always be output as a number, followed by a decimal point, followed by the fractional part without any exponential syntax. So you won't see any e's at the end of the number. No matter how big it is or how small it is, it always uses the full number itself. So when I output pi and s and n this time, and we'll see what that looks like. So we're looking at the second block here. Pi is still output as 3.141593, slightly different from the precision in the first example. And again, I'll explain that a bit later in this demo. The most interesting part really is the second number, s. S was our big number, 1.989, followed by 30 zeros, and it's actually output it all. There's a little bit of a rounding issue here. The way it's represented the number internally is a little bit surprising. But effectively, that is 30 zeros worth there. Okay, and then 42 as output as 42.000. So in fixed format, you'll always have a number followed by a decimal point, followed by the fractional bit. So the opposite of fixed format, if I just close that example there, the opposite of fixed format is scientific format, which you can set up like this. With scientific format, it'll always display the E letter and use scientific notation. So when we output pi and s and n this time, and see what that looks like. So we're looking at the third block here. It's always output as a single digit, followed by a decimal point, followed by a fractional part, followed by an E number. It seems a bit excessive here. Effectively 3.141593 times 10 to the power 0. So the E plus 00 seems superfluous, really, here, but that's what scientific notation means. You'll always see numbers in that same kind of format. Likewise, the next number is a single digit and a fractional bit, followed by an E number. And 42 is output as 4.2 times 10, effectively. Okay, so that's what scientific format gives you. At the end of the example, I want to reinstate the default format. In other words, I don't want scientific and I don't want fixed format. Now, unfortunately, there's no manipulator called std general. In order to reinstate general format, you have to unset the bit mask to do with fixed format and the bit mask to do with scientific format. And that's what we've done here. So this is the only way to reinstate general format. On the cout object, I call the member function setF, or unsetF I should say, and I unset this flag, fixed, and I also unset that flag. Effectively, when you call the fixed manipulator, it sets this bit. And when you call the scientific manipulator, it sets this bit. So what we're doing here is we're unsetting both of those bits to undo fixed format and to undo scientific format. In other words, we end back with general format. Okay, so at the end of the example, when I output pi, s, and n again at the end, they appear as they did at the beginning. At the beginning, they had general format like so, and at the end, they have the same format as we started off with. Okay, while I've got the output window here, I just want to talk a little bit about precision. Precision is different depending on what format you're using. If you're using general format, then precision means the number of significant digits. So at the first example here, when we're using general format, remember at the beginning we're using general format here. With general format, we have by default 6 significant digits. 1, 2, 3, 4, 5, 6. Whether it's before or after the decimal point, these digits are significant. Okay. However, when you use fixed format or scientific format, precision means the number of digits after the decimal point. So that's quite a subtle difference. So in the second block of examples, where we have fixed format, we have 6 digits after the decimal point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 6 digits there. And likewise, when we have scientific notation, it also means 6 significant digits after the decimal point. 1, 2, 3, 4, 5, 6. So the default precision is 6. You can change the default precision by using the set precision manipulator. So at the beginning of the example, let me just uncomment this statement. I've set the precision to 4 now, and I'll run the application again, and I wonder if you can guess what's going to happen now. So in this case, in general formatting, so at the beginning here, when we have general formatting, the precision of 4 means 4 significant digits. 1, 2, 3, 4. 4 digits that mean something. Whereas for fixed format and for scientific format, the precision of 4 now means 4 digits after the decimal place. 4 digits there, and there, and there. 4 digits here, here, and here. Okay, so that's a bit confusing perhaps, but just something to be aware of. So that concludes the example. I'll just summarize. We have 3 different formats for outputting floating point numbers. We have general format, which is the default. It chooses the best way to display the numbers based on what they are. And then we have fixed format, and we have scientific format. And if you want to reinstate the general format, you have to use this rather clunky syntax here, but that is the best way to do it. That is the only way to achieve that effect.